Hello and welcome to the instructional video for 3D printing support material. Today we're going to discuss how to avoid this happening to you, which is to say you're trying to print an L bracket indicated in yellow and you have all of this excess support material indicated in green. We'll cover three main topics today in this video when discussing support material considerations for 3D printing. We'll talk about print time, we'll talk about the effect on the part's surface finish, and we'll also talk about soft and dissolvable support material. When considering print time, it's important to remember that all material flows through the printer nozzle at a set rate, whether or not it's the part material or the support material. Therefore, if we can limit the amount of support material used, we will directly limit the amount of print time our part will take. The second consideration is effect on the part's surface finish. For most affordable 3D printers, they only offer an option for breakaway support material. This means that the material cannot be dissolved with a solution, and that it needs to physically be broken off at the interface between the part and the support material. Oftentimes, as you'll see in a minute, this leads to jagged edges and surfaces that need to be post-processed following printing. The last thing we'll talk about in today's video is dissolvable support material. Most high-quality 3D printers offer this feature as part of their lineup, and although most affordable printers do not, they are discussing incorporating this into their lineup in the near future. Some advanced manufacturing needs will require the use of dissolvable support material, and towards the end of this video we'll cover a few examples that will hopefully help to clarify when using this feature may be useful for you. Knowing these 3 points in advance will help you to plan your prints accordingly and diminish the amount of time it takes to get the parts you desire. Let's go through a few examples here. As shown on the screen is a very simple L bracket and a sample printer tray I drew in SolidWorks. Here, if it's in this position, you can imagine all of this area underneath the overhang will be filled in with support material that I'll indicate here in red. As we saw in that initial clip of the video, this is not desirable and will result in a very long print compared to if we oriented the part in this way. When it's in this configuration, there is little to no support material that will be required on most printers, provided this vertical segment is thick enough to prevent warping. A third and final configuration for this type of L bracket would be on its side, and again, this configuration would result in little to no support material on most printers. Now, let's try for a more complicated scenario, in which case our L bracket has two mounting holes, as you can see here. If we choose to orient it in this way, the overhang, just like the first example in the last demo, will need to have support material. In addition though, if we zoom in and take a look at the holes, they will also have to have support material to prevent the hole from collapsing down on itself. So let's look at the example of what the result is, as we showed in the beginning. If we were to print it in this way, this is the resulting piece. You can see there's a large amount of support material here underneath the L bracket, and as you saw before, that material was also filling in the holes to prevent collapse. At the bottom of the part, there's a brim here, as you can see, and as you can imagine, despite removing the material taking a little bit of time, that print took much longer than it had to because it had to print all of this excess material. Now what we'll see here in a minute when the support material is fully removed is what I meant when I said that breakaway material can lead to less than ideal surface finishes on your part if not considered. Now let's consider another example, putting this L bracket on a side. As you may have imagined, these mounting holes will need to have support material fill them in order to avoid them collapsing on itself due to the effect of gravity. Now here's a scaled down example of what you can expect. For this I used the print settings of brim on the bottom as well as support everywhere. You can see the holes have been filled in with support material to avoid them collapsing on themselves. And the brim, as you can see here, is very flexible compared to the raft. Now a third configuration we can imagine with the holes on the vertical surface here. As I'm sure you pictured, support material will be needed again to fill in these mounting holes. Now this is done in order to avoid them becoming distorted during the print time. Here's another scaled down version of what that would look like, and you can see the brim on the bottom again, as well as the support material filling in the holes. Now as a final configuration option, envision putting the holes on the bottom surface. In this configuration, most printers will not need any support material for this, provided that that top overhang is thick enough to avoid warping. Now let's take a look at what that part would look like. You can see here even the brim material is removed underneath the holes, and this part was successfully printed without any support material utilized. So after quickly removing the brim, we have our finished part with two uniformly circular mounting holes as well as no support material and therefore no jagged edges, ruining our surface finished part. Now there's also an option to print without support material on these lower resolution printers. Let's consider this part, for example, the fancy chicken model, and take a look in particular at its legs, which are very thin and delicate. Now in this example here, I printed it with a raft as a base and support material everywhere. And you can see that the support material here completely encases the legs, which would make it challenging to remove without breaking them. And you can also notice the raft, which is the thick layer on the bottom here. Here's another example in which I printed with support material everywhere, but with a brim as a base. So you can notice really the only difference is that the base material is much thinner and easier to remove than the raft would be. As a third option, I printed it with no support material used whatsoever. And for this piece, you can see in the example that it actually turns out pretty well. Some areas of the chicken are a little distorted due to the lack of support material, but it had very little effect, and most notably avoided the legs and feet being fully encased in support material, giving us an end result much more similar to the original file. Now here I've shown all three examples side by side so you can really get a sense as to how your print settings will impact your final part. Now from this example of the fancy chicken print, it may seem that using no support material is always advantageous. That's not the case, and you can see that based on this L bracket example with 2 mounting holes. Now here I used brim settings with no support material, and you can see there's these non-circular holes here. Let's talk about why that happened. Remember that the brim is here, and therefore during the print itself, gravity is pointed in this direction. With that being the case, as the material is coming out of the nozzle and is hot and malleable, when you desire these fully circular holes, they in fact sag a little bit at the top and create these flattened off oblique circles. And that may be fine in this part because it can be touched up on the drill press, but for many other parts with harder to reach areas, it's much more crucial to get a higher precision part. Now right now I'm showing another example of an L bracket where the same result happened. Again, let's walk through briefly why this happened. You can see here that gravity was pulling towards the brim itself, and during the print job that resulted in the top of the circles having some sag to them and leading to less than ideal results from the print. Now if you're really committed to using as limited support material as possible, it's all about positioning your part correctly, as you can see here in this example. Remember back when we decided this was the best orientation? This resulted in no support material, perfectly uniform mounting holes, and no distortion to the surface finish of our part. So, thus far we've covered topics of discussion on print time, as well as effect on the part's surface finish. Let's round out this video by talking about dissolvable and softer support materials and when they can be useful. As an example, let's consider this design part. We'll go through a couple of the reasons why this is a great practice piece. On the top surface, there's a few blind holes and a blind cut through the E and the I respectively. On the front surface, you've got some through cuts in the D, the E, and the S. On the bottom surface, there's this deep channel here that we have to account for. And then most interestingly, on the D itself, it's made of 2 parts where there's a mobile inner component and a fixed outer component for it to slide within a sheath. So let's consider this part and print it on multiple machines to see how the different support materials and orientations make a difference. We're first going to print it on the Ultimaker, and then we'll print it in the upright position like this. Now when the part comes out, it's filled with breakaway support material, as you can see, jammed into every crevice of the part. Now we'll take it back to the benchtop using some tools, remove all this support material, and take a look at what it looks like. After a great deal of work, it's somewhat a respectable part. You can see that the support material has been removed in between the letters. You can see as we move to the bottom surface here, that's been removed, but it's still quite a rough surface finish, as we talked about earlier in the video. Most notably, the D is immobile, and that's because there's some support material between the outer and inner sheaths. Now we'll print it on its side, still on the Ultimaker, and you'll see that there's some interesting changes. The D is actually mobile, and that's because it was printed on its side position and there didn't need to be support material built in between those 2 sheaths. Now you can see those holes on the top surface are pretty imprecise, and that's because there was support material built in there. But overall, a pretty decent part for just changing the orientation. Now looking at them head to head, on the top you'll see the side print, and on the bottom you'll see the upright print. And there's different components about each of them that are better or worse than the other. But ultimately it speaks to the importance of orienting your part correctly, and I'll cover that in more detail in a future video. Now let's print our part on the Formlabs printer, which also only has breakaway support material. And interestingly, the Formlabs printer prints the part upside down, and it leads to this interesting lattice work of support material as you see here. Typically the best way to remove that is with a cutting instrument, and this is what it looks like after removing all of that support material. You can see there's a handful of nubs remaining from the removal of the material, and most importantly that D is not mobile because there's support material still between those two sheaths. Otherwise it's quite a smooth surface finish, and we'll talk about in our follow-up video why that's the case compared to the FDM printers. Now we'll print it on the Objet, which has soft but still not dissolvable support material, and you can see here it's a wax-like substance that comes out in support of the material. And using your finger, you can almost scrape it off as you would imagine with wax. And after taking it to the water jet, which you can refer to my other video, the part comes out just like this. And it's almost the best scenario. Extremely clear, the D is mobile, all these blind holes are very clean, all of the through hole cuts are extremely clean, the surface finish is extremely smooth as well. So from an SLA printer perspective, this is the way to go. Now we'll print it on the Dimension printer, which in some applications can have dissolvable support, but ours in the lab does not. And this is what it comes out looking like with support material in place. Notice how clean the holes on the E and the blind cut on the I are, and that's because this was printed in the upright position, as you may have guessed. So all of this support material is breakaway. Let's take it to the bench top with some tools and remove all of it. Now here's the result of the support material when the part was printed on its side rather than upright. And you can see that there's still some retained support material in places that are too hard to remove, and the D is still immobile. Saving the best for last, we have the Uprint, which does have dissolvable support material. And here's what it looks like when we print this part, first thing coming out with all of the support material. It comes out looking similar to the Dimension print, except there's one main difference. Can you tell the orientation it was printed in? If you guessed on its side, you'd be correct. And you can see the D is immobile and the support material is still all throughout. But the beauty of dissolvable material is that after putting it in a basic solution for a few hours, it comes out like this. Without any mechanical removal or use of tools, all of the support material is removed, and you can see the surface finish is really as good as it gets. Now this is definitely my choice among all the printing options for this part, and because of the dissolvable support material, you don't have to worry too much about how you orient the part. Now to further demonstrate the utility of dissolvable support material, let's consider a dynamic part like this adjustable or crescent wrench. It uses a worm drive, as you see here, to adjust the jaws, and you can imagine there are many regions that would be hard to remove support material to make this work correctly. In the red you have these notches, in the yellow the area around this guide pin, and in the green the area adjacent to each of the threads. Now here's what it looks like after cleaning up the support material from a Dimension print, and as you may have guessed it, the breakaway support material does not allow this worm drive to properly function. So I printed it on the Objet, removed all the support material with the water jet, and you can see that the worm drive is clear of all support material, and now you have a fully functioning wrench where you can adjust the distance between the jaws. Now as one final fun exercise to discuss dissolvable support material, I created a ship in a bottle type project, and this question mark represents a surprise piece that I placed inside this fully enclosed cage. This cage has no way to get into or out of it, so we'll demonstrate the dissolvable material. I printed it on the Uprint. Here's what it looks like coming off the tray, and you can tell that the surprise part on the inside is still unclear because it's fully encased in support material. So next up, I'll put it in the basic solution bath, wait approximately 4 hours, remove it from the bath, clean it with water to get the highly corrosive basic material off the part, and now it's time for the big reveal. As you can see, it's extruded CBID letters standing for Johns Hopkins Center for Bioengineering, Innovation and Design, and because the support material was fully dissolved, this extrusion is free to move on the inside. So this concludes the instructional video. I hope it was helpful to you. If you have any questions, feel free to reach out to me or any of your professors or TAs, and in the meantime, happy 3D printing.